Hi everyone, this is our data source analysis showcase slideshow. Uh, my name is Brandon Lahomore, and my two other peoples are Julia Lehman and Thomas Taylor. And for the open slide, I want to start with New York City open data air quality from 2009 to 2022. And this data set contains information on New York City air quality surveillance data. Air pollution is one of the most important environmental threats to urban populations, and while all people are exposed, population emissions and level exposures and population vulnerability vary across neighborhoods. Exposures to common air pollutants have been linked to respiratory and cardiovascular diseases, cancers, and premature deaths. These indicators provide perspective across time, New York City geographies to better characterize air quality and health in New York City. Data can also be explored online at Environmental Health and Data Portal, which is that link there. I'll show you in a minute. There are about 18,000 entries in this document, and data is found there. So with that first link, it takes us here. And as you can see here, we can look at all the air data quality that is over here. So you have like surveys, you have real-time air quality, and there's just a whole bunch of data stories that we can see here tracking New York City's air quality. And what we have here is the data that that is like open data, open to the public that we can all see about the air quality measurement, and it's very interesting to look at. So here we have the attributes of the data set. So we have unique ID, indicator ID, name, two measurements, geotype name, geojoin ID, geoplace name, time period, start date, and data value. And what that means is unique ID means unique record identifier. Indicator ID is identify the type of measurement, value across time and space. Name indicator, measure, how to indicate is measured, measure, another measurement, which is the information about the measurement, geotype name, and geotype is UHP, which stands for United Hospital Fund Neighborhoods, for instance, TDY, BRA, and community districts, or different geography types. GeoJoin ID, which is the identifier of the neighborhood, geographical area, which is used for joining to map geography files to make thematic maps. GeoPlace name is the neighborhood name, time period, description of the time that the data applies to. It could be a year, range of years, or season, for example. Start date, the value start of time period. Always the date value could be useful for plotting a time series. Data value, the actual data value for the indicator, measure, place, and time. And for that, unique ID, the type of data types. I'm gonna go through them. Unique ID is a text, indicator ID, number, name is a text, measurement is a text, auto measurement is a text, geotype name is a text, geo ID is a text, geoplace name is a text, time period is a text, the start date is a floating timestamp, and data value is a number. So our analysis from the graphs of the data set we have created since 2019, there has been an overall decrease of particles, PM2.5, in multiple areas in New York. Based on the data, because of the fact that the amount of PM2.5 in the air is lower, the overall amount of emergency department visit decreased. I would like to possibly look into how the ozone has affected your city, because that is another data set we can look at as well. So to look at these graphs, to start off, if you don't know what fine particles are, they are called the PM2.5s, which these cause great risk to health. They are also the main cause of haze we see in the USA, mostly seen in national parks and wilderness areas. And now, so if we look at this graph from 2009 to 2022, in the Bronx, it has decreased by 5 mcgs, and we can see that that graph started at 11 and ended at 6. Um, as we see in the Bronx also, there's a chart that shows a spike in asthma emergencies, um, and it's per 100,000 children. So if we look at this graph, um, we can see it going down, decreasing, and then out of nowhere, in 2000, 2005, 2007, there was a big spike, and since then it has went down, a steady decline between 2007 to 2019. And then in Brooklyn, the fine particles um, is a little bit above 10. It has decreased 4 to 5, ending at 6, 6, and it's just a little bit lower. It's ended at the same time during 6, but it's a little bit higher at the starting point. In Brooklyn, so also in Brooklyn, the acid emergency departments, due to the fine particles, there was a peak in 2005, 2007 as well. And as you can see here, um, it is at 100, and at the time between 2007 to 2019, it has a steady decline until it hits just below 60. And so we see here, the fine particles in Bayside and Little Neck is actually lower than the Bronx and Brooklyn. It starts below 10, so it's between like 9 and 10. And at 2009 to 2022, it ends at 6 as well. So it's around the same ending point as the other two. So we can see here, once again, at 2005 to 2007, it was at the high. Not as many people, um, probably because of the population size in that area. Um, Not as many people, but there was a huge spike in 2005, 2007, and a big decrease between 2007 and 2019. And as we can see here, the graph is starting to go up more. So if I take my cursor, it's starting to increase a little bit more once we get to 2015 and 2017. And then finally, Manhattan, uh, which is our highest point, starting point in 2009, which is right a little bit above 12. And as we can see here, it just gets under 8, which we'll say it's 7 in 2022, which is one of our highest points for fine particles in Manhattan. And as we can see here, obviously Manhattan being such a bigger area, as well in 2005, 2007, where there was a huge peak, one ending at 180 per 100,000 children. So if you calculate that, that's a lot of people. Um, but then there's a steady decrease from 2007 to 2019, which have we seen in other graphs except for the Bayside and Little Rock, which has started to increase a little bit, but not by much. And that is all the slides. I appreciate y'all taking your time to watch our video and our the analysis source showcase. And I hope you learned something new today, and I appreciate it. Thank you.